Today we'll discuss about this 2D polar coordinate. So as you know that in 2D you have two coordinates, that is x and y. So that is the right-handed coordinate system. So this is known as the Cartesian system. But let's say you have a circle of radius r here, and this is, let's say this is r, and you want to represent a point here, and the circle is making an angle theta with the x-axis. If you want to represent the x coordinate of the circle, you will get that x is r cos theta, right? And if you want to represent the y coordinates, y is r sin theta. So for any coordinate system, the you need to choose two basis vectors that are in case of Cartesian, that is we have x, y. But the rule for choosing a coordinate system is at that the two vectors should be linearly independent, that is x and y are not dependent and towards each other, that is there exists no relation such that you can represent y as a function y in terms of x. You can represent y in terms of x. So that's why these two coordinates are independent coordinate. So and then and the second criteria for choosing a coordinate system is they should be mutually perpendicular. So in our case, this x and y, these two coordinates are mutually perpendicular coordinate. So any sets of vector that are mutually perpendicular and they are linearly independent are they form a coordinate system. So in our case, if we choose our first vector along r, that is let's say r cap, and choose another vector along the perpendicular to that r vector, let's say name this direction as theta, and this direction is r. Then if we define the unit vector along r, then we let's denote it by r cap. And if you want to define the unit vector along theta, then let's denote it by theta cap. And by construction, that r cap and theta cap are mutually perpendicular, that is their dot product is 0. So if you want to represent this r cap as a function of r and theta, as a function of theta, let's extend that line to here, right? Now if this angle is theta, this is perpendicular, then this is let's say 90 minus theta, right? Now if we draw a parallel line here, this and these angles are equal, right? Because these two are parallel. So if you want to break this r component wise, that is one component is parallel to x and another is let's say parallel to y, then what is our r? R is r cos theta x plus r sin theta y, right? And what about that theta? Theta is, if you want to break, then theta, if this angle is theta, this angle is also theta, because this and this is 90 degree, and this and this, if you add these two angles, these are also 90 degree, so these two angles are equal. So what about theta? This is the minus x direction, so theta is that is minus r sine theta. If this is theta, this is r sine theta, and since it is in the negative x direction, this is minus r sine theta x cap plus r sine theta y cap, right? So what is mod of r? Mod of r is basically r square cos square theta plus sine square theta, that is r, that is as expected. And also mod of theta is minus r sine theta square plus, sorry, this is a typo, this is r cos theta, right? Since this is theta, this component is r cos theta, so that is r sine theta square plus r cos theta square, that is again r. So what is the unit vector along r? That is r cap is, if we divided this by r, that is cos theta x plus sine theta y. And what is the theta cap? Again you divide by that theta r, that is the mod of theta, then it is just minus sine theta x plus cos theta y. And if you take the dot product with r cap and theta cap, you will see it is minus sine theta cos theta plus sine theta cos theta, that is 0. So r and theta is perpendicular as expected. And what about the linear dependence? So whether r and theta is linearly dependent or they are linearly independent. So for any vector to be linearly dependent, then let's say first let's say that theta cap is linearly dependent to r cap, that is theta cap is some constant, let's say that is c times r cap. Let's claim this. So if we disprove this claim, that means they are linearly dependent, and this is the proof for this is the formula for linearly dependence. If they are linearly dependent, then we can express the theta cap as some constant times r cap. So let's first assume they are linearly dependent, then disprove this fact, this claim. So then only way we can prove that they are linearly independent. So if theta cap is c times r cap, then our cos theta is, our minus sine theta x cap plus cos theta y cap is c times cos theta x cap plus sine theta y cap. That is, if we take the component wise part, that is sine theta equals to c cos theta and cos theta equals to c sine theta. Okay, from this thing, from first equation, this equation, you will get c equals to minus tan theta, and here you will get c equals to cot theta, right? So that is minus tan theta equals to cos theta, cot theta, that is minus sine theta by cos theta equals to cos theta by sine theta. That means sine square theta plus cos square theta is 0. But that is not possible, you already know, because you know from the basic trigonometry that sine square theta plus cos square theta is always equals to 1. So this is not possible. That means our theta and r are linearly independent and they are orthonormal to each other. That means they forms a rectangular coordinate system. So this is our introduction about the 2D polar coordinate. So now we'll apply this principle to our, let's say, circular motion first, and then we'll generalize this to any non-uniform circular motion where the radius is not fixed, it is changed. That is, the magnitude of the radius, that is RT, that is mod of r prime t, that r is a function of t, that r change, that means the radius changes with time. That is this kind of motion. Let's say here you have a radius at time t1, here it is at time t2. The magnitude of this is not equal to magnitude of this. The same for here, here, here. So here the magnitude of r as well as the direction of r is changing. So in the uniform circular motion, we have the r, the magnitude of r is constant, but its direction changes. That is, here let's say this is a circular motion. Here the magnitude is constant, but the direction is changes. But here both the magnitude and the direction is changing. So that is, so this motion is non-uniform circular motion, and this motion is uniform circular motion. So we'll discuss about this, we'll analyze all the kinematics of this non-uniform circular motion in the upcoming lectures.